Ladies and gentlemen, good evening. Thank you for joining us. I'm Jaime Correa. I'm an associate professor in practice at the School of Architecture of the University of Miami and the coordinator of this lecture series. On behalf of our Dean, Rodolphe El Huri, Dean of the School of Architecture, and Tecnoglass, our sponsor, welcome to our lecture series of the spring of 2021. But before we start, let me remind you to keep your microphones off at all times. This will facilitate the smooth deliverance of the lecture without unnecessary interruptions. If you're attending the lecture for the sake of continuing education credits, which the so-called learning units, please acknowledge your presence through an email to Professor Stephen Fett. His email is sfett@miami.edu, or you can send him a chat message also. He will write, please send him a private chat message so that not everyone sees what you're talking about. He will write his email on the chat window on the right-hand side of your screen, but it's sfett@miami.edu. At the end of the lecture, we will have a panel discussion between distinguished professors Juan Alayo and Dennis Hector. Tonight, we are honored to have James Carpenter from James Carpenter Design Associates in New York City, also known as JCDA. James Carpenter Design Associates is a cross-disciplinary firm which works at the intersection of art, engineering, and the built environment. This firm is led by James Carpenter, and it is recognized for its distinctive use of glass and natural light, both of which are the foundation of the firm's design philosophy. In search for that intersection between art and architecture, their work brings a certain sensibility to their projects and leverages glass in order to establish a dialogue between interior and exterior, or between natural and artificial light. This approach is evident, for instance, in projects such as those that he will present tonight in Jerusalem, or the recently opened museum at the famous Eero-Saarinen Gateway Arch in St. Louis, a project done more or less in 1963, or at the Gucci building in Tokyo. The firm is also noted for its activation of public spaces, including the monumental sky reflector at the Fulton Center and the exterior envelope and lobby of 7 World Trade Center Tower in New York City. The firm was founded in 1979 and has been recognized with numerous awards, including the National Environmental Design Award from the Smithsonian Institution and the American Institute of Architects Honorary Award. Mr. Carpenter received a MacArthur Fellowship in 2004 and the Daylight Award from the Velux Foundation in 2010. He is happily married with Tashiko Mori, the famous professor in practice at Harvard University. So on behalf of the School of Architecture of the University of Miami and Tecnoglass, our sponsor, please let us welcome James Carpenter.
Thank you very much for the invitation to come and speak at the university. We've not done any work in Miami, but hopefully that may be something we can work on in the future. But I'm delighted to have an opportunity to speak to all of you today about the work in my studio. And just in terms of prefacing our work, I would just say that I originally started studying architecture at the Rhode Island School of Design. And in the process of being at that school, I became very fascinated with many of the studios that exist there relative to foundry and machine shop and different materials facilities. And after a couple of years in the architecture program, I found myself drawn towards the film department on the one hand and the glass program on the other. And I began doing work primarily trying to blend those two things together. And some of that work began, you're seeing this image okay now? So anyway, I began doing a lot of work in the sort of early 70s that took advantage of this idea of working with the different departments at the school. And one of the areas I focused on was working in the film, and then film projections on glass occasionally, and then film installations in and of themselves. And some of this early work, this being a film done in the mid 70s, early 70s, represented in New York at some galleries here and in Europe, a film installation that deals with the migration of salmon, where there's actually a series of film frames, sort of a gantry built over the river with scaffolding, and a series of films shot down into the surface of the river that sort of capture the movement and migration of fish up through this small river managed by the University of Washington. And the intent of this is all about studying qualities of light and understanding how our eye tends to focus on certain components of the visual information field in front of us. And this sequence that you're seeing in real life is probably about 80 feet long, and shown in a gallery where you walk into the space. You're essentially sort of standing next to this river, observing this event happening. And by slightly altering the timing of the films, what you begin to realize the longer you look at this film, that the information you're seeing is not necessarily just the movement of the fish below the surface of the river, nor the bottom of the river, but in fact, sort of the reflection of the sky overhead. So this idea of multiple fields of information sort of overlaid on each other, both the reflected image and image contained within the material, image seen beyond the surface, this idea of layering of information or layering of fields of sort of qualities of light is really what the work is about. In this instance, this idea of the migration really sort of captures this way of sort of sending our understanding or ability to understand a context. Let's move this forward, sorry. And taking that particular project, this is looking at a later project, but a project that really relates to that salmon migration project. It's a small bridge done for a client out in California in the mid 80s, but it's basically a bridge, a glass platform about 100 feet long that sort of floats over the river, and it's accessed by two bridges or two abutments. So you essentially walk out onto the bridge from one side of the river, move along this glass platform to the other side of the river. And in that moment in time when you're actually moving or crossing the river, you're moving with the current or against the current. And the whole idea here is that the quality of light sort of falling on the surface of the river reflects back up and creates this sort of projection surface upon which you're walking. And this is a whole component of what we try to work on in the studio, where how do you begin to get people more deeply involved in a particular ecology, have the moment to take a break within their time of the day to realize that there's something else happening on, try to have that realization become a moment of meditation or a moment of repose or a moment of sort of collective understanding of qualities of nature that are around us that which we often don't pay attention to. So these earlier projects led to, I'm sorry, this keeps repeating, sorry. Led to other projects here in the city, and this is sort of jumping forward. I sort of mix things chronologically here, but they're all sort of linked together with this notion of light. But this is a project here in New York with Foster, a firm that we've worked with actually since very early, since the 70s. I worked on the Hong Kong for them a long time ago. And this is one of several things we've done with them over the years, but a building here in New York, the Hearst Tower, and it's obviously built upon this podium of the original building from the late 20s. And if you look at this podium, you'll notice the original entry, which is relatively small aperture into this stone facade on 8th Avenue, basically, very close to Central Park. And we worked with them on some of the issues of the clerestory and some of the skylights around the space, but primarily working on how you can bring light and the sense of light to the core of a building, inside the building. I don't know if you can see my cursor. Standing on the street here outside the building, looking in, what you're actually looking at is an inclined surface, which is in fact made out of cast glass. And the whole principle here is a very simple periscopic principle. We're basically taking the daylight coming through the clerestories, daylight coming through the skylights, bringing that daylight down to this glass surface. And then when you look from the street, you're basically looking into the building, seeing this glass surface, but your view is in fact looking back out at the sky outside. So the whole notion is sort of flipping the field of vision. So that's how it works with optics and daylight. And then a little diagram on the right-hand side is how it functions performatively for the cooling system of the building, where we're collecting rainwater on the top of the building, about 50 floors up, collecting the rainwater, bringing it down. There's a mechanical room behind this inclined surface where the water is purified and cooled. Then we're running chilled water over this glass surface. So it's sort of creating a type of cooling where you're sort of doing a stratification of cool air down where people occupy the space and sort of cool the whole area. But one of the programs I got most involved with, as you might gather from some of the images you've seen at RISD, was in the glass program. And a gentleman at the Corning Glass Works in the early 70s had seen some of the work I had done with film and glass together and asked me to come to Corning and work in their research and development lab with a fellow who was a very, very well-known glass and ceramic engineer. And I ended up working with him for about 7 years on and off as a consultant to Corning, but ended up learning an enormous amount about glass technology at a level that you wouldn't necessarily have access to in the commercial glass world. So it's led me to do a lot of projects with glass. And you're looking at a mold, basically a graphite mold. We make these molds and machine them out of graphite. All the details of construction are machined into the mold. The mold is actually filled with molten glass. So here we are. This is obviously the Hearst Tower in New York, and it is obviously a Foster building. And this is how we actually produce some of the glass materials, where it's actually a machined graphite mold into which the glass is poured. And you end up with getting these basically glass prisms that have all of the detail in them. And this glass castings are basically set up into the structure within the building itself. And it ends up leading you to creating this surface, which is basically bouncing that daylight from the skylights overhead and the clerestories and bouncing the light out towards you at the street. So whenever you look in the building, you're essentially looking up at the sky beyond. And then again, as I said earlier, that the water from the roof of the building is sort of brought down and chilled, and it basically runs down over the surface. So it's this whole idea of everyone entering the building sort of has this moment of time where they're sharing this particular experience of sort of getting up into the main lobby of the building. Other projects, and this goes back a bit ways, have to do both with working with architects. This is working with Vince James out in Minneapolis on a private house, where we worked with him on all the glazing and sort of shading systems for the building. But the building had one particular window, which is up here on this upper stairway, which is quite unusual in that it's a a project that was designed for an elderly couple who had a wonderful house in the country, done by Jurgala back in the early 70s, and they moved into downtown Minneapolis near the Walker Arts Center, and wanted a sense of privacy and living in nature. And this window here posed a particular problem. You sort of see it's a window on the stairway going up onto the second floor, but it's basically a window that's compromised from the point of view of not having a view. So it's facing directly a stone wall and a fence and a neighboring garage, and therefore isn't necessarily a view or sense of intimacy that they wanted to have in the building. So the window, again, just the connection here with the Hearst project is this idea of periscopic view. Essentially takes this little mock-up you see on the left, sky overhead, indicating clouds or whatever in the sky with these white squares. Those images are brought down into the window plane by a series of mirrors, inclined, and the lens is positioned at a particular focal length from the mirror, which then focuses on the right-hand side. As you see on the top left-hand corner, it's focusing the image of a tree in the distance, brought into the window plane and then projected. So it creates essentially an optical device that takes various information outside the building, projects it against this translucent glass surface, and you end up with this sort of reconstructed reality, basically almost a type of virtual reality outside the building, and just brings up the whole notion of how we treat windows. I mean, what Rudolph was mentioning earlier, how much glass there is in Miami and use of glass, but it has this other capacity to basically, basically construct its own worlds. And in this instance, you can see what's happening where you're getting an image of a tree in the distance. That tree might be 75, 80 feet away. You look at the top of the tree, you're getting direct shadows and projections of leaves from another area on the wall. And then you're getting these sort of pinhole camera images of the sun as they come through the leaves, projected on the glass wall. So those types of windows, I think, just bring up this whole idea that there is a lot to be done with apertures that we take for granted just as filled in with a piece of clear glass. But other types of apertures to be worked with is going to be sort of demonstrated on this project. And I'm going to come back to this tower here, Tower 7, but at the moment we're just talking about this project over here on Broadway, which is called the Fulton Transit Center. It's a relatively new transit center for the subway lines, the Transit Authority here in New York. And we won a competition to work on this building with Grimshaw. And our whole idea was how to bring more daylight down to the subway system as a means of wayfinding and sort of organization below ground. But the primary scope was in this head house or this main building. And the geometry you see in this drawing was the original geometry that was sort of anticipated for the building. But during the time sequence of this building, which was designed designed in 2004, 2005, during the financial crisis in 2007-8, we had to go back and totally redo the whole design for it. And this really wasn't finished till about 2015, I guess. But the nature of this, and based on this idea of how one handles an aperture for a window, this what you're looking at is a section through that main part of the building. Up above here is sort of an inclined skylight facing slightly south. And then below it is this tensioned net, basically, that comes down from a compression ring at the roof line down to the first floor slab here. And it's defined by a surface of optical aluminum in here. And I'll show you a little bit more detail about it, but the principle of this drawing I'm showing you is that if you stand below this and you look up, normally when we look at a skylight, our view of the skylight or the sky above is defined by these boundary conditions, the width or diameter or height of whatever the skylight might be. But by shaping this surface adjacent to the skylight and using a material, this optical aluminum, which captures light and actually captures image. You can see what happens if I'm standing at the center and I look over here, I'm actually looking at the sky at a great oblique angle. So basically the view of the sky seen with this structure is defined by the widest possible aperture. So instead of a narrow view of the sky, you're getting a full view of the sky. And it does multiple things when we think about it. There's a little mock-up of the material and the structure, very, very porous. The porosity is in fact designed for smoke evacuation. The whole smoke evacuation system for the whole subway line is behind this net. This is before the net is installed. All those upper floors are basically fan systems that exhaust the smoke. So this whole shape is what's referred to as a smoke reservoir in a large building. And the project is all built off-site. It's a cable structure, sort of arrives like a great big oriental carpet. It's all sort of predefined in terms of the indices of the different cables, tensioned at the top, tensioned at the bottom, and then these panels are essentially applied to this very lightweight cable net. And the purpose of the cable net in this instance is that it completely steps around the problem of most large-scale infrastructure projects, is that you are only on site for a very short period of time. You're not working here for weeks and weeks and weeks to do this. It gets done very quickly. There's very little interface with the existing building. So whatever discrepancies there are in the existing construction, it doesn't matter. This just ties out at two locations. It allows you to create a completely separate structure, lightweight structure within the building. Now, what it does is, I think, what's of most interest. If you look at this image still during construction, I use this one because the space is a little bit darker down below. But what you're looking at here, if you can see my cursor, you're basically seeing a cloud. This is a cloud overhead, back behind you, actually. This cloud is in the sky, way back over here. It's in a part of the sky you can't even see looking straight out of the skylight. Another cloud over here. And this is the blue of the sky, obviously. So the whole idea here is that you're bringing the image of the sky, you're basically folding it into the building itself. So it's no longer thinking of the sky being in space with you, like through a mural or a painting on the sky. It's sort of harking back to sort of this notion of like Greek theater, where you are under the sky. And in this case, in an urban environment, you're bringing the sky into the building. So the people gather here and they walk through the space. And it's honestly a type of view of the sky that you do not get in New York City any other way. If you step out into the street, your view of the sky is completely confounded by all the tall buildings and interruptions. You never have a sense of reading the sky as you would if you were outside of the city in nature. So that's what's happening here. You're sort of reconstructing an image of the sky and sort of changing people's connection to it in an urban environment. So that whole collective potential of having a work be something that excites people, it's sort of a moment of meditation or a moment of engagement for them on an everyday experience, I think is quite important. And then how this sort of plays out in sort of a larger scale is this tower, which we worked on quite closely with Skidmore, which is Tower 7. The project we just looked at is over here, which was done later. But Tower 7 was the first building built after 9/11, and it was there was another Tower 7 there that obviously came down. It's the building that came down through fire. Actually, it had a large oil storage, fuel storage in the basement, caught on fire, and the building basically collapsed in and of itself. So this building was the first one built after 9/11. It was sort of everyone's desire to have this building be emblematic of sort of the quality of construction and sort of a more public spirited building presence on the street, as opposed to the original World Trade Center, which was a super block elevated above street level and is really sort of a obstacle relative to pedestrian engagement. So this was obviously understanding that the roadways would be re-established. They had been cut off previously. And our work here was very early on hired directly by the owner to work with Skidmore on what could this building be in terms of having a sort of an activated surface or a surface that engaged with people. So the base of the building is about an 8-story concrete vault system. It's actually a power substation, occupied structure, steel structure above for the tower is above there. But this lower part of the building, wrapping that power substation, is a system that's really made out of prisms. Again, these are stainless steel prisms that have a slight finish on them. It's not polished, but it's just, again, a little bit like the quality of the material in that Fulton Street Center. You want a material that holds the light. You don't necessarily want reflected light. You want the light and image to reside on the surface of the material. And in this instance, this is the original drawing, which is just talking about how you can program the surface of the building to respond to available apertures in the sky plane surrounding the building. So if you have an opening between tall buildings, how do you use that field of light to activate the skin of the building? So working through a whole sequence of models, which we do to study these ideas, we ended up with this idea, which is basically 2 screens. It's sort of a heavier screen on the outer surface, a finer screen on the inside surface. It's about 8 inches deep. So that's the depth of the curtain wall. So an 8-inch volume width that starts at the curb and goes up to 800 feet in the air. That volume is the area that we're working in to activate the skin of the building or the surface of the building responding to light. So this base of the building, you can see the finish is slightly muted. It's sort of put together with a company we've done quite a bit of work with recently in Minneapolis. And they make actually oil field equipment and filtration equipment for water, large dams and things like that. They haven't really done any architectural projects. And these are all built by robots. And it's basically a series of prisms that you can see. If you look at it closely, one row of prisms is angled slightly. The other is parallel to the face of the building. And then this project is installed against that concrete skin that you saw. So daylight, the prisms that are perpendicular or parallel to the face of the building reflect one image. The adjacent panel reflects a slightly different image. So this outer skin deals with daylight. The inner skin deals with artificial light. So if you look at an early series of these panels going up in the building, how you're not really able to see through them. Your eye tends to reside on the surface. And here on the corner of the building, even though it's a concrete vault system behind it, your eye basically stops at this surface, even though the wall is 50% open, because one of the prerequisites for this is natural ventilation. So that air is able to flow through this wall to cool the transformers, but your eye actually stops at that outer surface and reads it as a solid. And then in the evening, there's a series of LEDs that illuminate that inner skin of the building. And then you have the same skin become something quite different in the evening. And it's actually linked to a camera recognition system. So it actually responds to the movement of people around the building. And the curtain wall of the building is also a daylighting system where the glass panels that run floor to ceiling, the ceiling up above here passes the floor line of an office, overlaps the spandrel section of the building, this being the structural section of the building, and then the next level starts again down here. But using the spandrel area as an open daylighting reflector, it's like a curved, slightly curved panel, and then an inclined reflector at the base. And the purpose you see here over on the right-hand side is basically, you can see there's blue color there. Daylight comes down, bounces off this, and as you can see, you're basically bouncing blue light back up into the shadowed area of this corrugated surface. So when you look up from the street, you see these as blue panels, which are designed, in fact, to merge with the blue of the sky around the building. So this idea of depth over the whole skin, the depth of the building at the base was light on the outer skin, daylight, light on the inner skin is artificial light. On the tower, you get light on the outer skin reflecting off the glass and view of the sky off the glass, and then a secondary quality of light behind it. So you're essentially layering glass, which is sort of something we work with a lot, is this whole notion of volumetric light. And this is, I think, critical to how one works with glass, is that the glass actually plays with multiple effects overlaid on one another. So your eye actually has a much richer and more active surface to read when you look up at it. So these are obviously full-scale test mock-ups that you look at when you're building a large-scale building like this. And this is basically how that daylighting reflector system works over, a 700-foot tall tower. Like this building, if you walk around it in the daytime, is always responding to the sky in very, very different ways, very, very rich ways. And people see this from, several miles away or uptown, whatever. But from the tower base looking up, that whole stainless steel skin then merges with that other daylighting system above the tower, but a way that the building becomes very responsive to people on the street and responsive to its particular lighting conditions. And jumping to quite a different context in terms of scale, this is, we've done several projects sort of in the Mideast, and Rudolph, we also worked with Vince James on the American University in Beirut campus, expansion of that campus. And this is on the campus in Jerusalem of the Israel Museum, where we were asked to sort of rework the campus to make it ADA accessible. And actually we removed several buildings and added about 5 new buildings to this very beautiful sort of collection of work from 1964 by an Israeli emigre architect. And that his work was basically these earlier buildings in here. And then a very interesting Danish architect was responsible for these additions back in the late 70s. His name is Jürgen Boe, who you might know his name from the La Louisiana Museum in Denmark. And then we were asked, and this is the building by skipping my mind at the moment. I'm sort of distracted by this whole Zoom conference call. But it was done by, it houses the Dead Sea Scrolls, and it's a beautiful little piece done in the early 60s as well. And our work was really this, redoing the whole garden, and then adding these new buildings and a new below ground passageway through the core of the campus, and then renovating many of the older galleries inside. The whole idea was to keep the scale of the original buildings, but to work with the daylight to create a very different extension and connection. So the excavation going up through the center of the campus, into which we installed this route of passage to the core of the campus. And then this is the new entry into the museum below ground in that environment you just saw. The difficulty with the campus was it exists on a hill, which is called the Hill of Tranquility, very beautiful hill, surrounded by a sort of arboretum. And the difference in elevation from the entry up to the actual entrance, you had to climb all these stairs, was about 45 feet. So what you're looking at here is a tunnel where you start about 18 feet below ground and you're about 60 feet below ground up here, and how one keeps this whole daylit environment feeling continuous and connected to gardens and courtyards that come down adjacent to it. These are the original buildings, so we wanted to stay at this sort of scale, which is very beautiful with the landscape. As you can see, the original buildings were actually all concrete, and then they're clad in Jerusalem stone. And obviously the way they dealt with daylight in those days would have been to the west, south, and east, very narrow slot windows at the top of those boxes. And then at the north, maybe a deeper daylit area, which still gets daylight, obviously in that latitude. But anyway, you try to cut down the light through the narrower windows. But we developed the system for these buildings. This is basically a model of an extruded terracotta piece that you'll see how it's used on the east and west elevations. And this particular piece, which is used on the north-south elevation. So these are, they're louvers, but they're really not louvers. They do several things at once, but here you have the east-west one, and you can see that it's oriented perpendicular. So this clips onto the building. This is a vertical surface on the building, and it has this slight aperture carved back. Same on the north-south, it's a vertical section, then a deep, slightly curved horizontal section. And this is actually what it does with daylight. So noontime angle hitting east-west, light comes down at a very sharp angle, hits this cove, and then that light bounces up and illuminates the inside surface, the back surface, with bounced light. So it's actually a device which is a shading device, but it's in fact also a lighting device. So all of the inner spaces are indirectly lit by the light coming off of these reflected light off the inside surfaces of the space. And the advantage of this is the east-west louver. This is a mock-up here in our studio. You can see them configured here. Daylight hits this curve here, and then you see what it does on the inside. You have no view, you have no direct view of what's going on outside. However, you get the color of trees, you get the movement of leaves, you get the movement of people. There's a different type of animation, more of a cinematic animation that comes through the wall. And then this obviously down scales the intensity of light in this environment. So this is sort of what you see. And this is the shape, the actual profiles of them, obviously how they're made, very similar to extruded, this is extruded terracotta, and they're projected out. The campus was oriented north-south, ideally, so that's what led to this solution. So this is a north-facing part of the building, and obviously south-facing over here. They use a very slender louver, as you just saw in that previous slide, so you can look right through this in the daytime. And this is the whole idea, is that the original buildings were all concrete, so you never knew if the museum was open or closed, or if there was activities or whatever. So the whole idea here is put right out front on the street, right across from the Knesset building and now the National Library by Herzog Demeron, across the street. You can actually see there's activities in the building, and these parts of the museum can stay open at all times. This keeps out 100% of the daylight. So you have no thermal gain in the building. So this is the whole principle of this building project. These are the north-south louvers you just saw. You can see out, they're connected to the landscape. East-west, you have a denser louver. The glazing here is simply laminated glass, totally clear, uncoated, laminated glass, and you're working in the Middle East. We were able to reduce the mechanical systems for this building about 30% because it gets no thermal heat gain. It's a very simple, traditional principle, and it's just rendered, obviously in a different way. All the circulation, as you saw there, is shaded. So you move through the whole museum in shade. That actually creates a little bit of venturi through these spaces, so there's nice wind. East-west, of course, we're on a hilltop, so we have literally horizontal light coming in east and west. So we had to block it. It was the only way to block it was to do that bounce light, so you can see what's happening. I mean, these trees now have all grown up significantly, but you get all of this animation, but you've knocked off all of that, the excessive amount of light. So here it is. You just sort of see you get this uninterrupted connection into the garden, which was done by Izumo Noguchi, actually. So very simple. Tried to use materials that related to the older materials. Created these outdoor, trellises and green walls so that you could have this sense of cooler environment. And then this is where you enter that tunnel, basically, or that below ground. You're down here, a garden on the other side, a courtyard. This is where people are walking to the upper part of the museum, up through that passage. There you are, you're here coming out of that passage. There's a green courtyard up there, so you feel the connection to the landscape. But in reality, ground is up here. This is the ground level up here. So you're that far underground, but you don't lose the sense of being in a daylit environment. And these are all, again, west light being shielded. And then in the evening, of course, sort of that day lit. And then this whole notion of this beautiful, just like in Beirut, these beautiful Mediterranean landscapes, which in the case of in Jerusalem, relatively high elevation. And of course, Jerusalem has that amazing, topography where it's all rising up to the Mediterranean, very moist, green environment. Those days when you get that weather condition from the east or from the west, and then literally a quarter of a mile away, this drops off the desert for the next 1,000 miles. So it's a remarkable place. And you can never forget, you get snow in Jerusalem. So it can be quite a changing environment. And then just a few things, I'll try to go through these. Sorry, I'm speaking so quickly. About a project in St. Louis that had obviously a lot of its many other challenges. This is done with Michael van Valkenburg, with whom we've done quite a few projects over the years. And this is taking the national park, which this is one of the earliest urban national parks, designed actually in 1948, 49 by Saarinen, and not actually constructed till the early 60s, and he never saw it complete. And the landscape was done by Daniel Kiley, probably the greatest American landscape architect of the last century. And obviously it was a very tired context, and nothing had really been done on this over 50 years. This is the excavation of the existing museum and what had been a parking garage converted into a museum back in the 60s, 70s. But the project had to do with connecting these grounds, restoring all the park grounds, reconnecting people to the river, redoing this whole riverfront. Our task is on the renovation of this museum and then designing and this entire new entry here that brings the entry of the museum closer to the city. So the city had always been cut off by this 6-lane cut highway here, and then surface roads on both sides. So one of the major elements of this project was covering the highway, creating a new landscape. This is Michael's work, of course, and there's a historic courthouse just off of that park. So all of a sudden, the whole project was to bring it all together. And the original entries were here at the base of the arch. So sectionally, the original courthouse, very famous courthouse, and the first courthouse in the west of the Mississippi, it comes down, steps down, cover the highway here, step down, and then here's our work where you're cutting into the landscape, cutting in again, then dropping down, and then connecting to that existing building you saw excavated. So the new work is from about here back, and then this goes down to the Mississippi River, so it connects the whole town. So because the arch obviously does never have, it's a monument, but it doesn't have a singular point. It has two points of meeting the ground. So it's always this notion of leaving the center point open. And Saarinen and Kiley had this whole notion of how one circulates through the landscape in this very organic way, where you're never like just axially cutting through it. So we worked with that in terms of the design of the new entry, which you see here in plan, taking on that whole same idea of entering, going around this sort of center point to the below ground space. So Saarinen with his original model here in Mississippi, and this is a little model here in our studio of the new entry, and then coming down into the below ground space. This is as it existed before the project came about. You have surface roads, all the highway buffering, all the signage for the surface roads, all this sort of rather mean sort of crossings, other surface road over here, and then 6 lanes below you between those two. And then you go over, and this is the original, I have to say, this is a listed landscape. So that's the original elevation of the Kiley landscape, which we couldn't alter. We obviously took it all away and had to bring it back to that same elevation. So the project had to exist between that elevation height and then this boat wall height of the highway. So all of our work had to work between these two elevation points, which was quite difficult. So these elevations, you see the highway being covered here, surface roads are eliminated, excavation of the original buildings, the work on the excavation of the new space. You see some of the new entry forming here. And then as the work progressed, going through the project. So this is sort of the completed work. But again, that's this whole notion of circulating in, you circulate around to come in, or you circulate down to the exits that come out of the arch now. So it's more of a one-way circulation. And from the top of the arch, sort of looking back at that park, this is before with the highway there, and then the completed connection of the park back to the city. So this entry is very low profile, but all of a sudden establishes this new public square, let's say here, and place of gathering between here and the downtown. And then some early models of those interior spaces. The whole issue here, this is our studio, developing the lighting system for the space in my studio. The whole idea was how to make it feel, even though you're going underground and going relatively deep underground, making it feel like you're in a daylit environment. So these two slides basically just illustrate that this is where you've come into that curved entry, fairly low opening. This is how that thing I was just describing, we couldn't get, this is actually the squeezing between these two fixed points, this upper point and this highway point, bringing people in, threshold that sort of moderates the change of light levels, so it feels like you're entering a daylit space. And this photo actually shows you sun coming in, and then that sun here is striking this back wall about almost a football field deeper in underground. So it's all designed about bringing daylight in. So here's sort of an image of that, sort of that interior space, daylit sort of ceiling. Looking back, you can actually see the courthouse here from the furthest reaches of the museum. And then this sort of new established public space done with, obviously, again, Michael Van Valkenburg in his office, and sort of our component of this in there. So just two quick little projects to finish. This one, Harvard Business School, very small pavilion, sort of commissioned by the dean of the business school. And it's, funny enough, sits within the quad defined by all these brick buildings, both historic and new, by many people we all know well. Stern for one, around it. So it's one of the few modern pieces within this context, but it was meant to be a completely open pavilion year round, some protection wintertime where you can close off that translucent glass space. There is some heating there, but it's primarily oriented. This part on the right-hand side is south facing. So when the trees shed their leaves in the winter, gets warmed up by daylight in the winter, that south corner, and then obviously shaded by the trees in the summer. But it basically serves as an adjunct to this large auditorium here on the right. You can come out here. There's a tent system that attaches to this where they can entertain for receptions or lectures afterwards. But a very simple sort of pavilion done in that context. And I'll leave you with this one last project done for Stanford University a few years ago, a competition again, which we prevailed on, but a project that was not built. But this is Palo Alto, and some of you, if you know the West Coast, what happens, these are the mountains that separate the Pacific, which is obviously relatively cold water, and fog sort of works its way up these mountains and then sort of drops over the hills in the evening. And you get these residual fog banks that cling to the redwood trees and the surrounding trees, but they create these very beautiful sort of forms of light. And the commission was to come up with an idea for covering this sort of a little amphitheater, not so little, it seats about 8,000 people, that's now been surrounded by many new buildings However, the plantings around it have remained. And this was a very much of a core to the campus originally. The Olmsted entry is just up here. So you're very close to the original campus. And all the early great events at the university, all the graduations used to take place in this amphitheater. These are obviously these great concerts in the 60s with Jefferson Airplane and The Who and everybody, Joan Baez, I think, here. But what they wanted to do, the president wanted to do, is there are trees sort of intermixed with the seating here. He wanted to be able to cover an area that would seat about 2,500 to 3,000 people, which could be, a class or a graduation of one of the schools, like business school or one of the environmental schools, and not necessarily have it for the whole amphitheater. So what we did here is, you can see it in section down below, responding to the curvatures of the bowl itself, taking this form, which sort of nests down relatively low in the space and below the treetops of the surrounding woods around it. And sectionally, there's a space for events at the back here, a storage area here for the fabric roof that deploys, the new stage and all the acoustical things that go into the building. And then it's actually designed, as many of our projects are, we try to work obviously with natural systems, with nature, like on Israel, natural ventilation on many buildings. And in this case, using the cool air that's trapped below the trees, and by covering the grounds in the daytime, summer daytime, keeping it cooler, and then pulling the roof back at night, allowing the cool air to drop down. And you can change the temperature of this outdoor space by up to about 6 to 7 degrees. And just the reverse in the winter, you can open it up in the daytime, allow the grass to heat up, and cover it at night, and you hold that warm air down in the space. So this is the sort of the layout of that, that particular space. And I simply put this in as a closing because it speaks a lot about, I think, our aesthetic in our office. Is it's trying to find ways of creating spaces which connect very directly to their context in terms of the nature and sort of ecology, and individually have people feel like they are basically sort of embraced by these works in a way that sort of, I think, talks about tactility, it talks about community, it talks about intimacy, talks about shared experience. And that's something we try to sort of engage with in all of the projects. So in this instance, what you'll see happen is this fabric deploys in the space. It actually captures the sky, of course, overhead, but it also captures the shadow of the surrounding trees. So it sort of feels like you're in this much more intimate environment that has a lot of the activation, much like in Israel, how the movement of the leaves or the trees through the Louvre systems, or how you might be sitting in there and see the movement of the trees, or the change in sunlight as it falls below this at sunset. You get these raking shadows over the fabric and the roof. But trying to do works which are very sensitive and very well engineered and crafted, and trying to do things which people can enjoy and have a longevity to them in terms of reconnecting us to elements which we think are very significant in terms of improving our public spaces and our engagement with others. So I will leave it at that. And I very much apologize for the beginning of the lecture, and I apologize for racing through this. But hopefully, I know I just went on and talked about things technically, but hopefully I was able to communicate some of the ideas of how these work conceptually, and how all of this work, even going back to the salmon migrations and how you observe the image of the sky on the surface of the water. There's a thread to all of these things, regardless of how we respond to something. We always try to bring some sense of a vision of how to engage with with every particular context and the uniqueness of that context. Not necessarily just the uniqueness of the light, but both light, image, and ecology at once. So I'll leave it there and be very happy to answer any questions, should there be any. Now, I'm not sure I can hear you there, but
So thank you very much, Mr. Carpenter, for a wonderful presentation. Now let me introduce our audience and you to Professors Dennis Hector and Juan Alayo. Dennis, you're on.
Okay, thank you very much. And that was really an incredible delight, Jamie. I've appreciated hearing your description of the projects, and there's so many different aspects that I think are interesting to explore with you. But one of them that I think I would like to start with, it comes from a conference presentation you made, which it strikes me as particularly pertinent because you describe glass as mostly as a material that can be better described as a state in which a material finds itself. So there's a kind of animation that you ascribe to it, and then you said you're interested in the simultaneity that glass possesses. It's dense and it appears weightless. Its mass is literally transparent. So, I mean, one of the things I appreciate is the kind of manner in which you animate your collaborator glass as you're working with it.
Responding to that, I would say, yeah, that's, I think that's been an ongoing and ever exciting and ever surprising exploration with glass. I mean, I think that I mentioned to you, I had an opportunity. It was very, I was fascinated with glass to begin with because I got involved with it as a student at RISD. And obviously our opportunities there were to work with the material on more of a hands-on basis. And obviously we did a lot of work, but I think what was mostly taken away from that experience at RISD was the infinite means of basically this fluid, how one works with a fluid that is very hard to, obviously impossible to touch, but has this infinite range of possibilities of forming itself. And the latter experience of working at Corning, the person I worked with, his name was Donald Stuckey, now passed away, but probably one of the most important glass engineers or glass chemists of the 20th century, invented glass ceramics and many, many other, hundreds of patents, and earned Corning many, many billions of dollars over the years. But he turned on for me, and I was just a very fortuitous invitation to go there because they were interested in what I was doing with film on glass. And this Dr. Stuckey's, Donald Stuckey's interests were in photosensitive properties of glass. And this is something we never even talk about typically when architecturally, but when I got involved with this and the material we came up with was a sort of a modification of a material that was developed in the 50s called photoform. It was a glass that you could have obviously certain elements in it, has many different chemicals in it that has phosphor and other chemicals in it that allow it to be responsive to ultraviolet light. So you could, it looks like a normal piece of glass. You could lay like a photographic negative on it and put it out in the sunlight, or you could scan it with an ultraviolet laser, either whatever way, you're exposing it to ultraviolet light. But the area of glass that was exposed to ultraviolet light has what's called a latent memory to it. And people don't think about materials like glass, but it has a memory to it. And these materials interact with each other over time. But with this particular material, you can trigger that reaction with heat. So you expose it to ultraviolet light and then you heat it. And then immediately where it was exposed to ultraviolet light, a crystal grows. And then that crystal can be eroded with particular acids. So it was actually a way of chemical machining glass, but it's fundamentally a ceramic matrix crystalline matrix within a non-crystalline solid. So that's the interesting thing about glass, is it's one of the only materials today that lacks a proper definition or a proper understanding of its structure. The historic definitions of glass are supercool liquid or non-crystalline solid. Today, it's thought of as more in this context of something called jamming, soft matter physics, where particles or molecules are so densely packed, they become a solid. They're not a solid in the sense of a crystalline structure, it's just packing. And that's one of the more contemporary ideas. And glass is not the only material that becomes solid through jamming. Certain metals are jammed, and they're quite different. They're like certain steels, like stainless steel. They can be created through jamming and not allowed to sort of take on their normal properties. So anyway, glass is, for me, not to belabor this whole world, which is somewhat infinite to my mind, but glass is a material that constantly needs redefinition, and it can respond to that redefinition in any number of ways. So I see it as a very much of an active material. It's not a static material, and therefore that's how we just just in our studio we just sort of think of it that way. So that leads you to perhaps thinking about materials differently, that they have a life to them. So,
I mean, do you want me to continue, or do you want to?
Please, yeah, please. Well, I can go on
Okay.
forever. So, but that may just be too singular.
No, it's a fascinating approach. I mean, and I'm also thinking of Bruno Taut and Scheerbart and that whole era of glass architecture and the incredible promise that they imagined for in Alpine architecture. But one of the comments that Bruno Taut made was that in sort of trying to, I guess, shake off a reputation of being what he called a glass architect, was that he ascribed himself as accepting the attribution of being an apostle of color, because he said delight in light is the same as delight in color. And I know you've worked, I mean, you talked about a lot of color this evening, but you've also worked with dichroic glass, and you seem to have an amazing, a broad appreciation of the color of light. And not only that, both in its capacity to reflect, but also its capacity to transmit light. And how do you conceptualize the colors that you're working with and the sort of palette?
Yeah, I'd say, yeah, we do work with color. I guess there was a period, of course, I mean, where you're quite right. There were projects we did quite some time ago, probably 30 years ago, with dichroic glass. We tend to work with that a little less these days because what was that tout expression, happiness without glass, how crass? I mean, that was sort of it can be, color can become something that's very much, very difficult to work with. But I think what they were onto, they're onto, I mean, there's so many different thoughts about color field theory, going back to the German theosophical sort of backgrounds, and they were very much a part of that. But they really did think of glass, you're quite right. They thought of it in a more, I would say almost in a more spiritual way, and certainly much more of a way of transforming society. I mean, it had an opportunity, and I sort of appreciate all of these, this whole energy and sort of directive that they took in the sense of elevating glass to to a place or a position that had the ability to release us from the normalcy of life, let's say. And in a way, that's a little bit, we're trying to follow that trajectory, not in a literal sense, but we do think that there are ways that glass can inform us of our surroundings in a much deeper way, and that can give us a more sort of immediate and perhaps a more thoughtful and perhaps a broader sense of interrelationship with one another. I mean, I think it has that potential. I'm not elevating this to a level of some sort of spirituality or something, but just saying that there are ways that we can connect with one another through particular environments that allow some of these, phenomenology to happen and take place, and be a participant in that field of phenomenology. So that's quite what I draw from. I really do draw a lot of my inspiration from, it might not sound so interesting, but from fishing and being in water and on water, all times of the day, and trying to understand, this particular connection with particular species of fish. But it's this whole idea of light and water and that sort of interrelationship, and how it can be something that can take on so many different and so many dramatic sort of forms that we haven't had a chance to explore. So, and I think the other component of it, and then I think it was said at the very beginning, I've always had obviously a strong interest in nature. And in fact, when I was taught at the Rhode School of Design, I ran what they call their nature laboratory.
Oh.
And a lot of my time and through high school and early years at RISD, like I worked in the Amazon for a couple of summers for a division of the Food and Drug Administration on collecting plants, and worked in Northern Labrador doing some things too. So I've always, like when I was younger, a lot of travel, and was very involved in botanical expeditions and stuff like that. So that's very much a part of my background, and not that I do that anymore, but it was very much a part of my going to RISD first of all, and then also eventually finding my way to sort of to a practice. And I guess for students, a practice which, as it was defined in the introduction, we sort of work between engineering, which I'm very interested in and quite knowledgeable about, structural engineering, and then materials, glass obviously being one of them, and then architecture, although I'm not an architect, but with the built environment. I mean, how do these different disciplines, fine arts, engineering, architecture, how do they interrelate? And so we see our studio as being bounded by those, but by not being defined as any one of those, being an artist or an architect or an engineer, I think it gives us a broader sense of flexibility, in the sense that we can respond to different opportunities with an emphasis on one of those three things greater than another, depending on the challenge. And I think as a practitioner today, I think that on the one hand, it's confounding and sometimes maddening that we don't have a clear definition of what we do. We can't just say, oh, I'm an architect, and then there's an assumption of what that is, obviously. But I actually like the fact that we live in this somewhat more open context. It's a profession, certainly, but it's not so clearly defined as others. So I think there's something to be learned from that, from the point of view that as a career, it's always been very uncertain where your next project comes from. But we've basically just followed, sort of opportunities, and they have taken us in many different directions. And as we built our practice from smaller projects into larger projects, clients or whoever have recognized what we bring to a project and have given us more responsibility in those projects. So anyway, yeah, I mean, material science is of great interest. I've taught at MIT in the material science department.
So thank you, Dennis. Yeah. Thank you, Dennis, for your questions. Let's go to Juan now.
Great.
James, thank you for the presentation. We had a chance to meet a long time ago when I was working for Gary Handel, and we were working on the Millennium Project that you did, the installation talking about dichroic glass.
We go back a long ways.
Yes, we do. But anyways, it's great to see kind of in this format really how, and I've always been following your career since then, since that experience. But I think one of the questions I have here is, well, one as it relates really to in your practice oscillating between installation artist, architect, engineer, like you were mentioning. And so how do you, well, first is how do you try to maintain a focus? Because it's, you know, we can name some other professionals who have maybe started in one way and then veered off completely in another and stayed to that. But I think you've been able to kind of maintain a focus with respect to the exploration of the material, of the exploration of the sort of basic ideas. So maybe if you could speak also just for the benefit of the students in this room, you know, your collaboration with architects, how you've seen your role change, or how do you shift when you're the lead or when you're asked, you know, say like in the Hearst building where your contribution is limited, say, to a spatial experience versus at Seven World Trade where it was different, or like in the museum in Jerusalem where you have a much bigger role. If you could maybe discuss that.
Yeah, it's you know, it's interesting. I think that, so you go back, actually let's just go back to where we last met, I guess. So that's a project. Let's see, I should probably go back a little bit further. I showed you some work early on of the films. And I probably didn't explain those very well, but I did the film work probably from early 70s, like 72, 3 until about 81 or 82. I was very active in the art world here in New York and in Germany and Switzerland, where we used to show quite actively. And there's quite a few of those film installations in museums over there, which they were certainly more interested clientele than the US at that period. And at that point in time, my work was really very much about creating film installations, which were in fact creating spaces that were constructed by multiple films. Like I showed you the one of the salmon, but many of them sort of occupied a whole room using different films to create these spaces. And they all had to do with natural history or natural phenomenon in one way, shape, or form. And that was very much a part of the whole sort of environmental art, sort of conceptual art that was happening, you know, in the early 70s and through the 70s. You know, and I showed, you know, with, you know, like Vito Conchi and Dennis Hoppenheim, we were all in the same gallery back in the early 70s. And I began to, I had all these other experiences, like working at Corning. My income at Corning sort of helped pay for the films and that type of thing. I always tried to keep a lot of these multiple interest areas open. And what happened, I think, towards the end of the 80s is the art world began to shift rather significantly. It went from work that was certainly much more conceptually based and sort of, let's call it non-product based, to work that, you know, basically is really about products, or where the art world is today still is just, you know, painting, Sandro Chia and Schnabel, I mean, all the stuff where you're just generating product. That's a very different type of art world that I lived in, which was certainly much more about ideas and conceptual ideas and how you use those ideas and communicated those ideas, in my case, through film. And then that change in the art world sort of made me to begin to think about, well, instead of putting all this effort into something that might exist for 3 weeks in a gallery here and 3 weeks for a gallery there, or a museum buys it or something, how can I start doing projects which have longevity to them and also are engaging with the public? So you have sort of a different audience. You have an audience that's not conditioned to a gallery. So you're talking about trying to engage people, you know, intellectually as well as physically in something that they maybe have not been familiar with. And that's sort of early on that the reason I showed that first glass bridge project, which was commissioned by a family in California, was that was one of the early projects of like going from a film installation that dealt with migration to floating this sort of glass platform over the water surface. So it picked up those characteristics of the context, but actually established a moment in time when people would interact with this, but have a different relationship to that ecology than simply crossing the river. You actually have a moment in time where you are part of that ecology and move to the other side. So it's like trying to find a way of building things that responded to their context and engage people with that response, that capability of response. So the work sort of went that sort of trajectory. And then coming back to the thing that both you and I met on, that was really a finite commission, like on a building. So it was just X number of square feet and very much sort of a determined area to do something. And as you know, what we did was a project that actually has a back wall that responds to daylight, but it had these glass fins coming off of the surface that pick up ambient qualities of light and dichroic. So it projects light all over the surface. So if you're walking down the street as an individual, all of a sudden this wall, every time you walk by it, is completely different. It was trying to just create that type of awareness within people in that neighborhood. But doing that project and doing a few other projects with different people, like say, I know you had Tom Pfeiffer speaking not so long ago at the university. He and I have known each other, since Tom worked at Richard Meyer's office. And with Tom as the head designer of a couple of these big courthouse buildings, I was involved with him on doing, like, say, a special proceedings courtroom in Phoenix, and then, working on projects of his here and there as he felt there was an opportunity to collaborate on things. And then more recently on the Salt Lake City courthouse, where we worked on the whole curtain wall system. There are multiple avenues where, I'd say with Tom, it's a very close collaboration with a very good friend, and we share ideas and share thinking about light and materials very much. And when there's an opportunity, we try to work together. Other cases are, where we're sort of part of an arts program that's determined by whatever, an airport or a municipality or community, and as an artist to collaborate with an architect on a building or a public space. And that can range from being a more finite engagement, or it can be a more comprehensive engagement, just depending on how that relationship goes, or the flexibility or desire on the part of the architect of how much they wish to collaborate or not. So it varies enormously project to project. However, I'd say today, a lot of clients have sort of recognized what we do. I mean, sort of like Israel, that was basically a client who, interviewed several other architects around the world, and actually came to us because of some work we had done elsewhere at a smaller scale, but he realized what we brought in terms of the materiality, and we would not have done as had a previous architect proposed for their site, not propose some big new public building, some big thing that sort of overwhelmed the rather intimate scale of that campus, but we would be someone who would come in, work with that scale, and sort of enhance the engagement and the intimacy of the individual within that very, very rich context of landscape and early buildings, 60s buildings. And so that takes a client who sees what we bring to a project and is willing to give us that level of responsibility, which is great. And that happened. We're just doing a little museum in Denmark now, which again, a client who realized what we might bring to a project. It's not a big project, but it's a beautiful cultural history museum on an island off the coast of Denmark, or actually off the coast of Sweden, but it belongs to Denmark. And those are cases just where the client, which you need a great client, you need a client that understands what you do, and you can have a collaboration with them, I think is one of the more rewarding circumstances. Or like with David Childs and Skidmore, who brought us into many different projects, including Tower 7. And then what happened on Tower 7 was we're hired in parallel. We're hired actually by the same client as SOM to work with SOM collaboratively. So we're not necessarily contracted through SOM. But we came to this point in timing where this whole idea of having a building respond to the qualities of New York and be a building about luminosity and activation of light became everybody's shared goal for that building. So both the Skidmore people and myself and Larry Silverstein. And many of the meetings actually took place right here in my studio. But that's again like everybody sharing in an idea that can become realized, throughout the building. So it's not like a singular piece, but it actually has the whole building sort of embedded with this whole sort of approach to activation of our environment. And it also relates to this other whole principle of, public buildings or big buildings like that sort of consuming a public resource, which is the sky. And then you have that boundary of that glass wall where you're privatizing public space. And how does that building give back to its environment? What's that collaborative effort being made by the building to sort of give back to its environment? So having it be responsive and sort of give back to the surroundings, sort of a quality and recognition of daylight that exists in that particular location. So anyway, it's hard to define. Each project is very different, and our engagement is significantly different from project to project.
Well, thank you very much for joining us this evening, and thanks to James Carpenter for showing us his wonderful work. Thank you, Tecnoglass, for allowing us to share it with our students and the Miami audience. And please do not forget to join us on February 24th to see the work of Lina Gomez, who is an architect with offices in Paris and Beirut. So she will be 6 hours ahead of us. So please remember that that lecture will be held at noon. So it will be January 24th at noon.
February.
February 24th at noon. So February 24th at noon from Paris. Thanks a lot, and please.
Well, thank you very much. Thank you.